In this tutorial I will give an overview of the Fuji PXG5 industrial PID controller and how we can use the auto-tuning functionality. First I will show how you can use the real Fuji PXG5 PID controller and perform auto-tuning. But if you don't have this Fuji PXG5 PID controller, then I have created an auto-tuning simulator that can simulate the auto-tuning behavior of this real Fuji PXG5 PID controller. So here you see the Fuji PXG5 PID controller. In this tutorial, first part 1, I will show auto-tuning using the real Fuji PID controller, and then in the second part I will show how you can simulate auto-tuning using this auto-tuning simulator that I have created. The Fuji PXG5 PID controller has also a built-in auto-tuning feature that we should use. So you set the auto-tuning in channel number 1, and then you have go to this AT for auto-tuning, and normally this is set to off, but when you set this value to on, the auto-tuning is starting. Typically it takes a few minutes, and then it finds proper PID parameters automatically. So let's show how we can perform an auto-tuning using this Fuji PXG5 PID controller. Let's see how we can use the built-in auto-tuning feature in this Fuji PXG5 PID controller. So I have the same test software here in the background, where I'm using a mathematical model and a proper DAC device. In this case, a USB 6008 DAC device. So I control this mathematical model that are implemented in software here by using this Fuji controller. So now you see the process value is 25, and the set value is 25. So now, as you see in the program in the background, it's running smoothly, and the process and the set point is the same. So now let's apply the auto-tuning feature, but first I'll just go inside and check the PID settings. So I click on holding down the select button for a few seconds, and then I can select between the different channels. So the PID settings is in channel number 2, so I hold the select button down, and then you see the settings I'm using now. P is 125, I is 20 seconds, and D is set to 0. So that's the PID settings that the controller is using at the moment. But now I will switch to auto-tuning feature. Then I just hold in select, and then the auto-tuning feature is in channel number 1. So then I go into channel number 1 and select AT auto-tuning is now set to off. So when I set this, change this to click on the select button in order to change the value. So now I change the auto-tuning to on, and this means that the Fuji controller will use the built-in auto-tuning algorithm in order to find an optimal set of PID parameters. So when I set this to on now and select it, go back to the main panel, you see this blinking. This means that the auto-tuning is set to on. And now if you see in the software in the background here, you see that the controller puts the value to 5 voltage and then put it back to 0 voltage. And then you see how the process reacts on this change, and now it goes back to 5 voltage. So basically this built-in auto-tuning feature changes the manipulated value between 5 voltage and 0 voltage, and then observe the output of the process. And based on that, it calculates a proper set of PID parameters. So typically this auto-tuning takes 1 to 2 minutes based on the process that are used. And when the auto-tuning is finished, as you see now, this blinking here is gone. So now the auto-tuning is finished, and the PID controller are now using the new PID settings. So let's go into this channel where I changed the PID parameters. I hold the select button for a few seconds, select channel number 2, hold the select button, and then you see the P now was 125, now it's set to 15%. The I was 20, now it's set to 17%, and the D settings is now 3.2 seconds, while it was 0 second earlier. So this is the new PID settings that the controller now are using based on the built-in auto-tuning functionality. So now you see the process value is 25 and the set value is 25, so let's just change it to 26 or 27, and let's see if the controller is able to reach the new process value or the new set value. So now you see when I change the set point, the controller starts to react and the process value are reaching the new set value. And as you see here on the controller, I changed the set value from 25 to 27, and you see the new PID parameters was working quite good, so it didn't take a long time in order to reach the new set value, which is now 27. So that's how the built-in auto-tuning feature is working. So basically just click select for a few seconds, go into channel number 1, and then turn on AT, which is auto-tuning, set it to on and select it, and then you see it starts to blinking, and the controller are now starting to find new PID parameters based on this auto-tuning feature, which is built into the PID controller. Next, let's see how we can use this Autotuning Simulator that simulates the auto-tuning feature that are part of this Fuji PXG5 PID controller. So here you see the example code that you can download from the web page, and the auto-tuning feature, you find it here under the black box models. So here you have a black box simulator for using this auto-tuning feature. So this is the black box itself, and here on part 2 you find an example how you can use this auto-tuning simulator. So here you see the black box auto-tuning simulator, and here you see a practical example where this auto-tuning simulator is used. So I'm using the auto-tuning simulator here in order to perform auto-tuning on the mathematical model like this. So let's see how we can use this auto-tuning simulator in order to find a set of proper PI or PID parameters for this given process. So here you see the example provided. So when you download and unzip this folder, it looks like this, and you just open the project file, this one, and then these files are open in the LabVIEW Project Explorer. So here on the black box you find the Autotuning Simulator, which is an extension to the ordinary Fuji PXG5 PID controller simulator. So this is the ordinary simulator for the Fuji controller, while this one is an additional simulator that implements also the auto-tuning feature. So this Fuji PID simulator part is almost identical, but in addition there's an auto-tuning feature. So typically you just use this one in ordinary controller and control system, you use this one, but when you're going to perform the auto-tuning part you can use this one. And then under part 2 you find this hill simulation and testing auto-tuning example. So I just open it. So it consists of 2 plots. Here you see the measurement value, and here you see the controller value. And here you see the block diagram or the code for this simple example. So here is the Autotuning Simulator, which is this one. And here is a mathematical model implemented for this air heater system. So then let's just run this application. I'm clicking on this run button, and then this pops up. And then first we start using the auto-tuning. We just need the process to be on the set value. So now the set value here is 22 degrees Celsius, and so far the process value is 22.1, so we just need to wait a short minute before the process value is equal to the set value. And now in this example, these example PID parameters are used. And now here we should start using the auto-tuning feature. So here we can select either a P controller, a PI controller, or a PID controller. So I'm using a PI controller in this example, and in order to start the auto-tuning feature, I just click here, start auto-tuning. And now the auto-tuning features or the algorithm for auto-tuning are starting. So it's just so you see the controller value goes from 0 to 5 voltage, back to 0 voltage, and it goes like this until the auto-tuning is finished, and then this turns green. It's not finished yet, and then a proper set of PID parameters are calculated. In this case, only PI parameters are calculated. And then when the auto-tuning has found proper PI or PID parameters, then you can choose to use these PID parameters. So when I click this one, these parameters here will be replaced by the PID parameters found by auto-tuning. So you just need to wait a few minutes in order to make sure that the auto-tuning is finished. So the auto-tuning is running now, and you see these pulses from 0 to 5 voltage on the control value here and here. I guess the auto-tuning perform a set of these pulses before it is able to find and calculate a proper set of PID parameters. So you just have to wait a few minutes before the results will pop up here. So when the auto-tuning is finished, this will turn on and these will be calculated. And also see here the behavior of the process output after these steps in the control value. There's a new step from 0 to 5 voltage. So now there have been some steps here. Perhaps there will be one or more steps more before the auto-tuning will be finished. We just have to wait a few more seconds. And also observe the output of the process like this. And now a new step from 0 to 5 voltage, and hopefully this will be the final step before the PID parameters are calculated. Yeah, as you see here now, the auto-tuning finished, was turned on, and a proper set of PID parameters was calculated. And you see, since I selected PI controller, only P and I was calculated. And now I can, so now this PID controller still uses the old PID parameters as you as you see here, but when I click use PID parameters, then you see the values from the auto tuning was now replaced here, and now the PID controller are using the PID parameters found from the auto tuning feature. And then you see so far the process value and the set point is the same, so let's just increase it to 23 degrees Celsius, and then you see the controller starts to react, and the process output starts also to reach the new set point. There was some overshoot there, but now it is stabilizing on the new set point. I can increase it even more to 25 degrees Celsius, and then you see the controller starts to react on the change in the set value, and then you see we are able to reach the new set point, which is now 25 degrees Celsius. So you see, by using this auto tuning feature, we was able to find a set of PID parameters that we can use and test on our PID controller. So that's all. So good luck with your industrial PID controller and the auto tuning feature. Thank you.